So guys, this is solving a compound inequality with the OR symbol. Okay, so when you see OR, remember what we said in lesson 1, that OR is going to have, it can have one of two answers. It can satisfy one of your inequalities, or it can satisfy the other inequality. Okay, so therefore, it's more than likely going to go in two different directions. So when we solve this, we simply solve each one of them by itself, alone. So in order to solve this first one, 5x minus 7 is less than 13, we have to understand this is simplified. We're good. That side simplified. We're good. So now go to the properties of equality like we always do. So take away the 7. We're trying to get x all alone. Remember, don't mess with the x yet. Take away the things that aren't with him. So when I take away this 7, since this is minus 7 or negative 7, we add 7 to both sides. So if I add 7 to this side, I get 5x only. And if I add 7 to this side, I will get 13 plus 7, which is 20. Then, in order to get rid of this, to undo your multiplication, we do the property of equality of division. So we divide both sides by 5, and x will be less than 4. I did not change the symbol because I did not divide by a negative. So one of our parts of our answer is going to be x is less than 4. Here's the other part. So in this case, already simplified, go to the properties of equality, use the subtraction property of equality, take the 3 out of there. If I take the 3 out, I'll only have negative 4x over here. If I take 3 away from this side, then it'll be obviously positive 11, negative 3. 11 minus 3 gives us 8. Now notice what happens here. I'm going to divide both sides by a negative. So when I divide both sides by a negative, the very first thing I have to do is switch the sign around to its opposite. This will give us x is less than negative 2. So we have two answers here. X is less than 4, x is less than negative 2. Now remember what I said. Most of the time, OR is going to go in two different directions. However, watch what happens whenever we graph this inequality, this compound inequality. So here's our number line. And I'm going to include negative 2, which will be here. 0 will be here. 1, 2, 3, 4 will be here. So watch what happens. If x is less than 4, that means we have an open circle on 4 because it's only a boundary because it's less than. It is everything that is included on this side. And it continues on forever. That's that piece. This also says x is less than negative 2. Well, if I have negative 2 here and the answers are less than negative 2, then it should also go this way. Now, here's what you need to make sure you understand. Negative 2 is actually part of the answer for x is less than 4. So we don't have to draw both inequalities here. We actually only have to draw one, which is this one. And the reason we draw x is less than 4 is simply because negative 2 satisfies this. Negative 2 is less than 4. 4 does not satisfy this one. 4 is less than negative 2 does not make sense. So when you create this, sometimes your ORs will actually run together. However, it'll solve both of them. So if I take a number that is less than 4, any number that is less than 4, so let's take 3. 3 is less than 4. Yes. Is 3 less than negative 2? No, it is not. So it won't satisfy that. So it can be either or, right? So or. So it has to satisfy one of them. If we take 1 or negative 1, for example, negative 1 is less than 4. Negative 1 is not less than negative 2, but that is why we call this an OR inequality. It only has to satisfy one of them. Even though the graph shows all of this, it only has to satisfy one of the inequalities. Okay, a little tricky. Be careful.